Good morning, students. Okay, so I think we have completed our gradually varied flow chapter. So today we will start a new chapter called rapidly varied flow or hydraulic jump. Okay, so I think that hydraulic jump we have already discussed. So here I think what is rapidly varied flow and what is hydraulic jump we have already discussed in the last class. So today first topic we are going to discuss is some examples of hydraulic jump, or you can say occurrence in field condition. Okay, you can see these figures here. You can see that first figure, we have a sluice gate here. We have a sluice gate and this is the level of water. Once you open the sluice gate, here the flow of water from a lower depth got rises to a higher depth. Okay, because here the cross sectional area is very less here, and once it comes out from this sluice gate, then he got the enough space to cover its height. Okay, so that is why your, if you can see, your depth changes rapidly. Okay, your depth changes rapidly, or you can say it's a very short span. Okay, so that is why it is called rapidly varied flow, or you can say hydraulic jump. Hydraulic jump is always from supercritical to subcritical. Okay, when your flow changes from supercritical to subcritical, then we can say it's a hydraulic jump. That means your critical depth is somewhere here. Okay, okay, this is your critical depth. You all know our depth of flow in supercritical is always less than sub. Sorry, in supercritical is always less than sub. Oh, sorry, critical flow. Okay, so that is why your YC is here somewhere. So your Y1 is always less than YC, and Y2 value is always greater than YC. So it will be somewhat like that: y1 less than yc less than y2. Okay, so this is one condition of hydraulic jump. Second one, this is very common, and I think we have already discussed also. When we construct a dam as an obstruction, you can see in the upstream, we can see gradually varied flow in the upstream. Okay, when the water overflows to the dam, it strikes at the downstream end because it's flowing from a very high head. When it strikes and then it jumps. Okay, your depth of flow before jump is y1 and after jump is y2. Okay, so this is also one condition where you can find hydraulic jump. Okay, you can draw these diagrams. Okay, here in number C you can see when you have a steep slope, and again if you change to the mild, then also you can observe jump. Okay, then in fourth condition, if you have any underwater obstruction, then also you can observe an hydraulic jump here. Okay, so you can draw these diagrams. Okay, this these diagrams are nothing but your occurrence of hydraulic jump in different field situations. Over. Okay, then we move on to the next topic. It's uses of hydraulic jump. Okay, this is the five most important uses of hydraulic jump. First one is as energy dissipator. Second one is to increase the weight of apron to resist the uplift force under masonry structure. Third is to mix chemical used for water purification in plant or in water plant. Fourth one, to raise the water level for irrigation and other distribution work. And fifth one, to increase the discharge of a sluice by holding back tailwater. Okay, so these are the most important uses of hydraulic jump. So you can write it down. Okay, there are many, but these are the most important uses of hydraulic jump. You can write it down all the five uses. Okay. Okay. So we move on to the next topic. Jump analysis in rectangular channel. Okay. So first you write down this equation. So this equation we have derived many times. Okay. So you can directly write down this equation. Okay. A1 x1 bar plus q square ga1 is equal to a2 x2 bar plus q ga2. So if you want to see this derivation of this equation, it's already there. Okay. So you here. Okay. From your momentum equation, and this is the expression. Okay. So you can follow. It's just for 5 to 6 steps. Okay. So this is the equation. Okay. It's already there. I am going to share with you this PDF file. So you can go through this derivation if you want again. Okay. It's just you have to use the momentum equation. Okay. From there you can easily find out this expression. So we are going to use that expression for jump analysis in rectangular channel. Okay. So for rectangular channel of bottom width B, we have considered the bottom width of the rectangular channel is capital B. Okay. So now we are going to substitute the area expression in this equation. Okay. So A1 will be your B into Y1 multiplied by X1 bar is nothing but your Y1 divided by 2 plus Q square by G is already there. Then again we have A1. A1 in place of A1. Again we are going to replace with the area equation, that is B into Y1. Similarly for A2 also. So this Y1 is nothing but before the jump, depth of flow before the jump, and Y2 is depth of flow after the jump. Okay. So this B Y2, and again for A2 bar is will be nothing but your Y2 divided by 2. Okay. So you write down this expression. And after this, now you have to divide the whole expression by 2 by b. Okay. Sorry, you don't have to divide, you have to multiply. Okay. So here is some printing mistake in the book. So you don't write divide, you write multiplying by 2 by b. So each term in the above equation. Okay. So in first term, if you multiply 2 by b, okay, so this b and this b will cancel out. Okay. What is will be left out? Y1 square. This 2 and this 2 will also be cancelled out. So left out term is y1 square. Hmm. Plus, then again you have to multiply 2 by b to the next term also. There will be twice q square 2 will be there. So this b square will be there, okay, and other terms will be left out. Okay, will be same as it is. Only that 2 will come, and here we have initially 1b, and if you multiply it by another b, it will be b square. Okay. Similarly, for this right hand side also, we have to multiply each term by 2 by b. It's multiply. Okay. You multiply by 2 by b to each term. After that, you have to bring all the y values in the left hand side. Okay. So here y2 square is there. If you bring this on the other side, it will be minus y1 square. Okay. And 2q square by b square is already there by y1. If you bring this here, it will be minus. Okay. So then again in this two term, you see twice q square g b square are common. So that is why it brings out, so 1 by y1 minus 1 by y2. Then we all know a square minus b square. We can write a plus b multiplied by a minus b. Okay. So here also y2 square minus y1 square, in place of this we can write y2 plus y1, y2 minus y1. Okay, and we solve this. Okay, y1 y2, so y2 minus y1. So this and this will cancel out. Okay, this term and this term will cancel out. So you bring all the y value in the left hand side, so it will be multiplied y1 y2 and y2 plus y1. Okay, and here in the right hand side it's twice q square g b square. Okay, but we know small q is nothing but q by b, distance per unit width. So q square by v square, we can write small q square. Small q square by g. 2 is already there and small g is also be there. Okay. Done. So after that, you have to multiply. Okay, so y1, y2 square plus y1 square, y2, and if you bring this in left hand side, it will be negative, is equal to 0. Okay, now it's a quadratic equation we have to solve. So what we do, we solve by using this equation: minus b plus minus root over b square minus 4ac by twice a. Okay? One we will take plus and once we will take minus. Okay, so this is a very common mathematics term. I think all of you know, when you have a quadratic equation we can solve in this way. Okay, so here we are neglecting the minus term. Okay, so we'll consider it a positive, and if you solve here this term, you have to consider one is a, b, okay, and c. We have three terms: one is a, b, and c. Okay, so if you put in this here, the second term, then square of the second term minus 4 first into third term divided by twice a. Okay, if you put, you will get this expression. Okay, you will get this expression. So this part you do of your own, and if you find any difficulties we can discuss later. Okay, okay, so if you solve by quadratic equation you will get this expression. That is nothing but your y2 divided by y1 is equal to half minus 1 minus 1 plus root over 1 plus 8 fr1 square. Okay, so if you are planning to write for any competitive exam, so this equation is very important, so you have to remember this expression. Okay, this is the relationship between your depth of flow before the jump and depth of flow after the jump. So here y1 is depth of flow before the jump and y2 is depth of flow after the jump. Okay, so this is very important equation. Okay, and this is very common thing. Okay, you can expect a equation, sorry, a question from this unit. Okay, so you always remember. And sometime in the numerical if you see that fr1 is not given but fr2 is given. Okay, so you need not to worry. If you reverse the thing, if you reverse the thing that is here, that y2 by y1, if you reverse the thing that y1 divided by y2, all the terms will be same, only here it will be fr2. Okay, okay, here it is fr2, others all the terms will be same. Here y2 by y1, if you want to write y1 by y2, then this fr is resembles to this depth value. Okay, so it will be fr2. Always remember, whatever in the denominator, that fr will come. Okay, so here is in denominator y1 is there, so it is be fr1 square. Okay, here in denominator we have y2, So you can see here it's FR2 square. So you write down this two expression, okay? I think we have another class. So after 5 minutes, you join again. Okay. There is a break of 5 minutes. After 5 minutes, you join again for the next class. Okay. And there we studies about the jump. What are the different types of jump is there. And then we solve few numericals related to hydraulic jump using this two equation. Okay. And we identify that jump is your weak jump or strong jump. Okay. Or medium jump. Okay, so you just disconnect now, and after 5 minutes again you join for the next class.